Recording in progress. Hello everybody, good afternoon. How's everybody feeling this afternoon?
Good.
Yeah. At least the weather's not terrible. Although we'll be in a basement for the remainder of the day, so. So, on the agenda today, we're going to introduce assignment 1. Please recall about this class that we have a fairly aggressive assignment schedule. We've got roughly 1 per week. Actually, I think exactly 1 per week, but no exam or a midterm, so assignments are the thing. I didn't quite get through our stuff on bash commands last week, so we'll finish that off. Then we will continue on, and hopefully we'll hopefully get everything done for this week. If not, we'll spill over to next week a little bit, but that's okay. It's all good. It all works out. It's all good. Because as we progress through the weeks, there is, normally going to be a certain amount of in-class time assigned for figuring the assignments out. So I'm kind of hoping that I can absorb a little bit of that as cushion for these slides running over, because I don't know. I'm just the talkative sort, All right. It's because I'm so enthusiastic for this material, I want to convey everything there is to know to you guys. So, let's talk about assignment 1. So, using screen capture software and a microphone, could create a demonstration video where you demonstrate the following using the Linux Mint image and VirtualBox. So, the video should be under 6 minutes in duration. The shorter, the better, actually. Get in, do the thing, get out. You don't have to dwell. The audio and video quality need to be reasonably good enough for us to mark the video. So basically, quality needs to be high enough that I can see what you're doing. If it's like compressed all to hell and I can't even make out what the words you're typing are, then okay, listen and listen well. Use video capture software. Do not use your phone to record your computer. If anybody uses their phone to record their computer, they'll get a 0. OBS is very easy to use. That's the one I recommend. And not just because it's open source, but it's also open source. So, within reason, we're not focused very much on delivery, but it's important that you provide a basic explanation of each step as you take it. It might be helpful to think of the video as an educational video that briefly describes the steps to perform a particular task. Unless otherwise stated, use bash shell commands to perform the following tasks in order in the demonstration video. So, this assignment is divided into 3 tasks, each of which having to do with stuff we covered in lecture. So, do you need me to go through all of these, or can you guys read? You want me to go through it? I can go through it. So,
like the 4, number 4 to 7,
these guys, 4 to 7?
Yeah.
Yeah, so create a blank file. There's a command called touch you can use for that. Create an empty subdirectory. That would be make dir. Put a copy of file.txt, named file copy into the subdirectory. That's a call to cp. Use ls to list all files in the current working directory recursively, including hidden files. I'm not going to tell you that one. You gotta look that up. You gotta use the documentation. But don't do that in the video. Do that before the video. And and then just do it in video. Okay?
I mean, is it in the module that for number 7, can we search it up in the module or look I look for it?
Well, one of the beautiful things is you can look it up any gosh darn way you want. I don't really care how you look up your information. I just care that the information you look up is accurate. The man pages are guaranteed accurate. Yes, create directories. Is there anything of any note here? Using a single command that will create a series of subdirectories. For that one, you might have, like, the secondary goal here is understanding file paths. I think we talked a little bit about file paths last week. We'll talk more about them this week. File paths are extremely important. Aha! This even says check the make directory man page. Aha! There you go. And then task 3 is grep. Has anybody heard of grep before? Yeah. So it's grep, not grape. Don't ask me what it stands for, I forget. But basically, it's the way that you use regular expressions to search the contents of files. So, yeah. That'll make a lot more sense once we've done it, because that's one of the things we're doing today. But such tasks as use grep to find any instances of the text xpath in any files contained in the /etc directory. So, quick little hint about file paths. Anytime you have a / as the first character of a file path, that is referring to the root directory. So this is actually part of the sort of stuff you need sudo access to that's outside your home folder, right? So root, etc. I'll show you guys how it works. You see it even says you need to use superuser. Use grep to find any instances of the text 2.1 or 2.2 in any files contained in the same. Yes, yes, yes. And that's it, really. You can either upload your demo video as an MP4 file called demo.mp4, or you can include a URL for an unlisted YouTube video in a plain text file called video.txt. YouTube is preferred. If you choose to upload an MP4 file instead, it must be playable on common video software, Windows Media Player, QuickTime. QuickTime?
I think that's for Mac.
Oh, is it? Oh, okay. I haven't heard QuickTime since like I was in high school, I think the last time I had to worry about installing QuickTime. Like something to do with Macromedia Flash. But yeah, so obviously though, the one that you actually want to use is, anybody?
Windows Media?
No. The open source one?
VLC.
VLC, that's right. Give the man a cigar. VLC Media Player. Check this one out. This guy. You know it's the right software because it's got the little cone. It's kind of interesting. If you end up somehow with like a region-locked DVD, whether Windows will play it for you is like VLC will play it for you. This is the best media player. And I'm not saying that because it's open source, but I'm saying that because it's open source. Are you guys detecting a theme in this class?
You like open source stuff?
open source stuff is the best, yes. If you, the exam that doesn't exist will only have one question, and it is open source the best? And the answer is obviously yes. But you have to write obviously yes, otherwise you don't get any marks. So, very good. Any questions about assignment 1? Hopefully that seems reasonably straightforward to everybody. Once again, for your video capture, for those of you who arrived late, if any of you decide that it's wise to do your video capture using your phone, trying to record you doing stuff on your screen, you will get a big fat goose egg. Please use proper software. This is the open source software which I recommend using, OBS Studio. Free and open source software for video recording and live streaming. Relatively quick and easy to set up. Download it for your thing. I'm pretty sure that they have it on like Mohawk apps as well, possibly. But anyway, that's the one. Use this one. Okie dokie. Any questions? All good? Not very talkative today. Well, I shouldn't say that. You guys are more talkative than my last class was. It was like teaching a morgue. Of course, that was like the class in server side where I was explaining how cursed PHP is. So. Actually, it's even worse than that. It was like but wait, there's more. It was that lecture. We stopped on this comic, which I'm not going to read in the interests of time, but it's a joke about editors. All right, moving on. So, we were talking about editors. Vim, Emacs, ooh. I need to get the VM up and running. All right, everybody, let's take a moment or two and get the Mint image up and running. I didn't bring my computer because I was having difficulty getting it connected to the Wi-Fi today. I unwisely decided to change my password, and just everything breaks, you know? There it is. Download you. Pretty good. So, the slides recommend, in the slides we talked about 3 programs, Nano, VI or Vim, Vim by the way is VI improved, or Emacs. Personally, I know personally the most about Emacs. Vim is perfectly acceptable. Nano, I don't want to be as disparaging about Nano as they are in these slides. Nano is a perfectly reasonable editor. It just especially while you're getting used to command line editing, Nano is probably a pretty good choice. But at a professional level, probably Vim. Emacs is a lot. So, recommend going through this at some point on your own time. Let's get that. Yeah. There we go. So, so this is kind of one of those instances where your skills become very siloed in the editor you pick. You should kind of just pick one and stick with it. Learn the key bindings, and then don't worry about Emacs. In fact, you should like look down your nose at Emacs people about how much less efficient their text editor is than yours, right? But yeah, Nano is also perfectly fine. So. Now we are going to talk about grep. Grep is a, so there are kind of three like finding things kind of functions that, or bash commands that eventually you'll have to know. Grep is the first one of these. Find is the other, which is a little more complicated to use than you might think. And then sed, S-E-D, which stands for stream editor, is the final, it's the completing the trifecta. So, let's imagine that you're in a situation, right, where let's say you've got a code base and you're trying to port it to the new version of whatever language it is, and one of the functions that they have, marked for deprecation for some time is finally deprecated, right? How do you find all instances and uses of this function across your whole project, right? Now, you could load that up into an IDE, right? And you could search it that way. But the IDE is going to be limited in what it can do and what it can look at. It certainly won't, it may or may not dig things up in documentation for you, right? grep searches file contents for text files, anything that's character encoded, right? This is what it does. It does so using regular expressions. So, how many of you have heard of regular expressions? How many of you have used regular expressions? A little bit. How many people are confident to assert that you are experts at regular expressions? I wouldn't even assert that about myself. A big advantage of grep is that you can search a lot of data quickly, right? Speed is your ally. This is also particularly useful if you're searching debug logs. Now, the concept of a debug log is probably something you guys have kind of encountered a bit, but you won't have had to pick through one before, right? So basically, what often happens, and you can imagine a server, for example, logging things, right? It doesn't necessarily even have to be a debug log. let's just say your server is keeping logs on the IP addresses of every packet it receives. And it keeps like a history of the last 50,000 packets that it received. Something like that. Let's say you're trying to pick through the logs for some kind of pattern because there's been a cybersecurity incident. Right? Do you do that manually? Do you do that by hand? No. You grep out. That's the verb. You grep out of files the references to a particular IP address. You enter it in as a regular expression. You execute grep, and it will pull all references to that. Now, this is not anything you can't do with a simple find operation in a text editor. Even bloody Microsoft Notepad can do that. The advantage of this is that it can operate over the whole file system if you want, right? You can do many files at once using grep. In fact, you specify to grep which files you wanted to search. Does that make sense? Sound good? All right, let me see if I can boot this thing now. Boot! There we go. So regular expressions, you kind of like, you don't necessarily have to use them with grep. If you just type a string, as long as it doesn't contain any of the regular expression control characters, it will just be regular string searching the way that you know it from, find operations in whatever program you have used before. However, you have a lot more available to you. So let's see here. What's the password again? There we go. Thank you very much. Well, it's so awful because like this morning I was able to enter it in like I was a wizard, but today it took me like 8 tries. All right, so let me increase magnification. There we go. Is this good? Can you see this in the back? Awesome. So I'm just going to quickly go into Documents and make a couple of text files. This is review of last class. Okay? So, to navigate into the Documents folder, CD for change directory, Documents. LS lists the contents. You can see that we have nothing. I can then use now, if it's installed. We'll see if it's installed. Data1.text. There, Nano is installed. Hello, this is some data. I hope you're feeling well.
Did you make that file already, or the data1.text file?
I did not recreate it. When you open a file name that has no file associated with it, when you save it here, that will create the file. However, since you mention it, I'll show you how to create one ahead of time. Save, Control S, exit, Control X. To just create a file, touch data2.txt. You can see that we have data1 and data2 as files which have been created. If we ask for the contents of data 1, you will see it's exactly what we entered. If we ask for the contents of data 2, it is an empty file. So far, so good. Question?
So none of you creates a file and immediately edits it.
That's right.
Then Touch is just create a file.
Yes. Touch does one, it has a couple of things it can do, but the two primary ones. It can create a new file that's empty. It also updates the timestamp to the current time. And it will do this for a new file or an existing file. So LSL, the L option gives you detailed file view. Right here you'll find the timestamps.
That's when the files were created.
This is when the files were created. Well, actually, this is date last modified.
Okay.
We've only modified them once. Now, if I, for example, touch data1.txt, you'll see the timestamp has been updated, but the file has not been modified. Does that make sense? There are certain tools that actually make use of timestamps in an intelligent way. Have you folks ever heard of make? Sometimes it's called CMake. Have you heard of a make file? Yeah. So make files are a little bit like a specialized kind of bash script, but what they were originally developed for is making C source code, or like building C source code. Now the way that things work in C is that you compile and then you link compiled files together to form an executable. In order to save time, because back in the old days compilation took a heck of a long time, right? Like you could be compiling a piece of code for hours or even days if it was large, right? Back in those days, every file you didn't have to recompile, you shouldn't recompile. So make is a system that looks at the existing timestamps to see whether, basically, was this source code modified since the executable was created? If so, recompile it. If not, don't. That's kind of the whole point of make. But touch is like a command that you could use to override make to have it recompile stuff that hadn't actually changed without changing it. Make sense? All good? Okay. Let's give that some content though, and just for let's say sudo apt install vim. Do I need vim? Did I get that right? Oh, there we go. Yes. Failed to fetch. Sudo apt update. All right. So another handy Linux tip when you're in the command line, use arrow keys to back through previously executed commands. Let's see. Will you work now? Yeah, there we go. It just wanted updating. There we go. Vim data2.txt. There we go. Now Vim is a little bit strange. You have to put it in insert mode before you can insert text. You do that by pressing I. Just press I on the keyboard, that'll put you in insert mode. Now, some text, doesn't really matter what. Escape, W for write, that is save. Escape, in escape mode, Q for quit, which returns you to your command prompt. And that's the basics. So, very good. We now have enough data to, do something with. So, let's go back into documents. So, grep. Grep requires you to provide a search string and a file name pattern. So perhaps modern from data2.txt. There you go. I am the very model of a modern Major General. Right? Grep has some options. For example, the RA flag in combination does a recursive search. Sorry, question?
Yes, I don't know what I pressed, now I can't escape.
You don't know what you pressed and now you can't escape. Let me see. You're in the man page. You escape. Maybe?
Choose not been.
Oh, you're in Vinland. You were in several sub-buffers.
How do I get there?
I have no idea. Right. Escape. Quit. There you go.
Thank you.
Normally a pretty good heuristic is to just repeat the command for getting out of get me the heck out of here a bunch of times and hopefully it works.
Is it usually Q for most things?
Oh, here's one actually. If you have a program that's taking a very, very, very long time, Control-C, as long as you're not in a program like Vim or Emacs that binds the control key, Control-C is your stop, it's your stop command, all right? And if you accidentally hit Control-S while in terminal mode, that doesn't save, that suspends. So basically your terminal will freeze, and you won't know how to get it back to be unfrozen. So here, let me file, new tab. Let's go spelunking. CD. Change directory to root. Sudo grep everything with recursively looking for the word cheese. Out of cheese error. There you go. Now I don't know why this is like highlighted like this, but look, a surprising amount of cheese in the Linux kernel. But anyway, this is taking a very long time. If you want to kill the process, Control-C. There you go. Again, stop highlighting. That is not highlighted. Very strange. C. That is stop. Stop, please. Please stop. Stop that. Okay? In formal technical language, what that does is it sends a signal. Signal is like a designated class of operating system flags. This one is sigterm, signal terminate. It just, it's the same as like Control-Shift-Escape in Windows and you end the task that's using the same mechanism. But you can see this is a lot less clunky, right? Okay. On that subject, one moment. I have to show you HTOP. If it's installed. Gotta install HTOP. Sudo apt install HTOP. So this thing is basically your, this is like your much better Linux version of Control-Shift-Escape. It shows you all of the processes that are running. It's showing you how many CPUs you have, how much memory you have allocated, how many threads you're running, all of that stuff, right? But perhaps most importantly, this is like the process that you can find processes and end them with. So for example, if I had Firefox running, right? Let's say Firefox wasn't responding, right? You go F3, Firefox, right? Where is it here? I have to. Yeah, there it is. You might have to like arrow back and forth to actually find it, but this is the name of the command, right? It's because I've got it in like blown up mode, but F9 allows you to send sigterm to a process like Firefox. So, yeah. So that's like how you do that here. Don't kill Cinnamon. Cinnamon is your desktop environment. Once again, this is Linux. The motto is read the manual, but HTOP is an extremely useful program, especially if something is not running correctly and you need to kill it. Okay? Any questions? Shall we continue with grepping then? So, grep with the recursive flag set, R for recursive. I usually use A, although I don't know what it means. Maybe I use it out of superstition. If I'm looking for like an instance of the letter A in documents, what do you mean documents, no such file or directory? Where am I? I'm in documents, that explains it, yeah. There you go. There you go. You can see that searching the documents folder, I have pulled out every place in these files where an A is used. Notice that I'm also getting what files these are in now, because I'm searching more than a single file. And there are options that you can set to pull out what line number the matches occur on as well. Make sense? But this is still a very simple expression. We can do much more complicated things. So this is usage. Grep pattern files searches for the regular expression pattern in the file or files specified by the wildcard characters. This is a regular expression. This would be a similar sort of thing called a glob pattern. G-L-O-B, glob pattern. We'll talk about glob patterns eventually. So for example, grep test in index.html searches, it's the one that I just performed for you. Yes. This is the most simple glob pattern that most people already kind of have picked up by osmosis. Glob patterns can get much more complicated than this, but can anybody tell me what that asterisk means? Everything, yeah. This is a multi-character match, right? So there are certain characters that you're not allowed to use in file names. Asterisk is one of them, and the reason is, in a glob pattern, that means match me all of the things that have a .js file extension, right? This leads to certain interesting results. If you use just asterisk, it means you are matching all files in the directory, right? So it's actually the same thing to say, search recursively on documents, or go into documents and search, search star on that, although you don't get anything in any subdirectories unless it's recursive. Make sense? So far, so good. Any questions? You had a question earlier?
Yes, and it was answered.
Okay, all right. So, the R flag searches all files, all folders and subfolders within a particular, like whatever you specify here. Oh, we should talk about dot. I think we got a slide on that coming up as well. Let's see here. We're going to talk about dot. Maybe it was earlier. Maybe it's in one that I haven't looked at yet. Okay. There are a couple of special file path symbols that you need to know sooner rather than later. We already talked about one of them today. /. If this is just hanging out by itself, it means the root directory of the operating system, right? If we have dot hanging out all by itself, that means current working directory. The folder that you're in is dot. Tilde is the home directory for this user. In our case, the user of this VM is called tooltime. So this would be /home/tooltime. But does everybody remember how a CS Unix URL is formulated? Right? Maybe. CS Unix dot blah 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 /tilde SA 000123456 / right? You guys remember the tilde?
Yep.
Yeah? That's what the tilde means. Alright? It's the home directory for this user. Ha! Revelations. Oh, there's one more, and that is double dot, 2 period characters. And this means up 1 directory. So where it's relative to your current working directory, right? It's just like bop me 1 up in the hierarchy, right? CD ... means go up 1 level. Make sense? So far so good? Any questions?
Like if you were to group them, what would the name of the group be like?
These guys?
Yeah.
I would call these special file path characters. Some of them are character combinations, but you know. And then throw asterisk on there for multi-character wildcard. Question?
How interchangeable is PowerShell to the Linux terminal?
Well, I'm not sure because I've never used PowerShell.
Recognizing kind of like familiar terms.
Probably fairly similar. Most of the difference is going to be the names of the commands and perhaps the availability of some of the commands. Like, it's kind of like
It's a hard question.
like that's kind of a lecture in and of itself. No, I love questions like that. It's if I were a better PowerShell user or any kind of PowerShell user at all, I might be able to answer that. But like I can only sort of vaguely say that you know, PowerShell is kind of like here's DOS but more useful,
Yeah.
right? And like DOS is like there are some things about DOS that I should tell you. Okay, so you know how like in Linux, Unix, Mac, everything, / is your divider between directories? Has anybody noticed what it is in Windows?
Backslash?
It is \. Yes. Do you know why? This is literally the reason. Because they wanted it to look different from Unix. That is literally the reason that they used / instead of / in DOS. So that is all I can say about PowerShell. But yeah, like it's gonna be like based on how things work here, but it's gonna have its differences.
Okay.
Like in general, like similar, like it'll feel similar to the touch, but the commands you use will be different and have their own way of doing things.
Right.
You know? Yeah, it's like, it's not like you can like take a bash script, change all the slashes and run it into PowerShell.
The first thing that came to mind was the Control-C, because it's the same in PowerShell too. If I'm running into something, Control-C is my get me out of here button as well. So
Yeah.
I was wondering, like I saw a couple of things. I know like it's not one-to-one. I just started noticing like small things like that.
Well, PowerShell is interesting, right? Because it's kind of like, it's an early attempt at, ooh, the Linux terminal is interesting and developers like it. I guess we need something like the Linux terminal because people hate DOS. So here's PowerShell. And then it was like, oh, people hate PowerShell and still just want to use Bash. So here's Windows Subsystem for Linux, you know? Sorry, just mind your feet and my tripod. There we go, I'll move that a little bit this way. There we go. All right, thank you. All right. That's not like school equipment, that's my personal property, so. Okay. So, searching file contents takes a lot more time than searching file names, right? So, you can often, like you saw how long it took me to search cheese in the Linux, in sort of the main folders, right? It was taking quite a while. If you know anything about the file that you're searching, such as its file extension, you can drastically reduce the amount of time that it takes to execute the command by using that information too. Does that make sense? Yeah. So, regular expressions. You put grep into regular expression mode by passing it the E flag, capital E. So, let me show you a website that will be helpful. Regex 101. This is a website that allows you to test regular expressions against some text, and you can sort of debug them. Unfortunately, regular expressions are programs. Programs encoded as strings. They are a form of processing called cellular automata. And, you know, basically it's a bit of, there's something like a state machine, but, you know. Let's grab the Wikipedia article on regular expressions. Here we go. Copy a bunch of text. Copy. Paste. There you go. Here is some paste. Here is some paste. Here is some text I have pasted. So, various languages use slightly different ways of encoding regular expressions. If you use the, it says PHP, but this is like, I believe this is also the Perl standard, and the Perl standard, I believe, it's like slightly different from grep, but you can get grep to use the Perl style regular expressions with another flag. But for basic stuff, it won't matter. They all do it the same way. So, for searching for FOR. Okay? What if I want just the word for? Because you can see that formalized also is hit by this, right? Well, you have to include the space character either before, after, or both. That gives you for, just the word for, right? Now, what if you want, for example, let me think of a good one. Let's say you wanted the word in, or you wanted the word to. You start to see the flavor here? So, the bar says or. I group characters using parentheses. So this matches all instances of the word in and all instances of the word to. In. To, in. Right? If I want, I can also throw in the word the, right? I can do it that way. Now, Batman. Right? So let's say I want to capture this, but I don't know how many nas there are. If I just search for NA, I hit all of those. But that's not necessarily what I'm going for, right? This is too many hits. Group them, and then, oh, you need a space in there too. Because the space is part of the string you're matching, right? Star indicates 0 or more instances. So this also matches nothing, right? Plus matches 1 or more instances. So this doesn't match nothing. So you see how I've got all of these purple lines in between here? Those are matches which are occurring against no characters, right? So that's not something you want. But if this string must contain at least one repetition of na, then you can put plus in, and you can see that we're just matching these. Does this make sense? So repetition. You can also do fun things. So, so this only matches, so this guy here is a range match. So it matches all characters between lowercase a and lowercase z. So, one or more character between lowercase a and lowercase z, the at symbol, the same again, .ca, will match email addresses which contain lowercase letters that end in .ca. It won't match, for example, let's see, person@gmail.com. That's not a match because it doesn't have .ca at the end. Question?
Is the plus sign acting as and, or is it acting as previously of the repeating a pattern?
Plus, in a regular expression, always means repeat the thing that came before me one or more times.
Mm-hmm.
So in this case, it's the thing inside these parentheses, which is that repetition. Actually, those parentheses might be extraneous now that I think about it. I think this might still work without them. Yeah, because those are still braces. There you go. So in some systems, putting parentheses on around things also make them a quote-unquote capture group. Capture groups in regular expressions mean, well, it's okay to identify where matches occur, but if you, like, a useful program should have input and output, right? It's not necessarily, like, the file line view is fine, but what if you actually need that email address pulled out and sent to another program or something, right? That is, capture groups are the way to do that. So if I put this whole thing inside braces, you can see that it's telling me I have a capture group. So this would be like output. When you use regular expressions in Python, they'll collect them all up into a list and you can access them by index. Does this make sense? Regular expressions? Any questions? So this stuff is stuff that you can do using grep and other things too. It's very, very useful to know how to do this. In this example, searching for errors between, 1 and 9. There we go. So, for example, regular expression, let's get a space character followed by an M. M or D. There you go. Every word that starts with an M or a D in those files. Make sense? Hopefully this makes some degree of sense. Okay. Regular expressions. Yep. These are useful characters as well when using regular expressions and grep particularly. When the caret character is the first character in the regular expression, this means that the pattern must start at the beginning of a line. So you can't have matches that start in the middle of a line or span lines. Well, maybe you could do spanning lines, but yeah. $, the pattern must occur at the end of the line. So both of those are useful things, sort of situationally. I've already talked about 0 or more and 1 or more. Dot is a wildcard character. So, for example, one way we could generalize this to not necessarily need just lowercase characters is to replace it with the one character wildcard. And dot is already its own wildcard. Oops. There you go. When you don't want when you want one of these symbols to be literal, you use a backslash to escape the character, the same way that you do like a new line, a tab, or a quote. Does that make sense? So, it's this regex 101 is very nice because it'll even like give you a little explanation of what it is that you're doing, which is like, this is a tool that I personally use when I need to write a regular expression of any complexity. So, there you go. Good. Question mark, match the preceding item exactly once. Well, that's not actually a good description of what that does. I think it makes it optional. So let's go back here. Go back to this stuff. Let's say there you go. Yeah. So the question mark just makes it makes the preceding thing an option. It can be there or it may not be there either. So, for example, F question mark OR matches for, but it also matches or everywhere that occurs. Make sense? Very good. I know this stuff is kind of dry. We'll try to get through it. If you want to specify how many times something has to match, for example, the password in this password database that I'm looking for is greater than 20 characters, right? Using squiggly braces and then the number, you can perform that type of match. Let's keep going. As I said, backslash allows you to ignore the special meaning of a particular character and use it literally as that character. And the vertical bar allows you to, it's an or, right? It allows you to match this or that. But be careful that it's not taking these items individually. You always have to be like aware of the operator precedence with these, right? So, for example, if I were to say, this or that, right? Well, that actually did work. It depends on which one you're using. Sometimes it would just like, sometimes it would bind like that. Depends on what type of regular expression you're using. What flavor, as the thing says. So here are some examples. This regular expression matches every occurrence of error or warning inside of the log. Also captures it. This one matches error 1, 2, 3, 4, 5, 6, 7, 8, 9. This one matches warning. It also matches warnin with no G, because that's 0 or more match. Right? Make sense? Output.txt $sign will match for any line that ends with output.txt in e.log, any line that ends with, right? And this one, error not 7 to 9 at the beginning of the line. Does this make sense? Good. So, we've tried it. Yes, good. I made an announcement about this. How many people actually played Terminus? Was it fun? Did you find it fun? No? Yeah? A little bit. It's not Terminus. It's just Terminus. So it's a little game developed by MIT to try to teach people how to command line. All right? LS, look around. Less, welcome letter. There you go, that's your welcome letter. CD, Northern Meadow. There you go. A plump but majestic pony prances happily about. There you go. Items, pony. Cat, pony. Yeah. Oh, command cat. No, no cat. Alright. Less. Pony. There you go. So the game does have, it's like a little adventure game, but it's like training you to use Linux commands. If you haven't done it already, highly recommend it. Go do it. Go play the game. That seems to be a Kate Beaton reference. If anybody knows that, probably not. Anyway, go play Terminus on your own time now. Alright. Okay, we'll call shell commands done then. Any questions about shell commands? Okie dokie. So, pipes and streams. So, in Unix, we run programs. Can anybody tell me what the purpose of a program is? All of you have been studying software for at least a little while now, so you should know what the purpose of a program is. Yeah.
To take input from the user and then give the expected output.
Sure. To take input from the user and somehow transform that into output. The only quibble that I would have with you is the term from the user. That's where we're going with all of this. It is true that, from the perspective of web development, ultimately everything results from a user. When you folks were writing your Java programs, you required an operator for that program, right? The power in the power of Linux and the power of the command line is to not require your programs to have a direct user interacting with it. You can write programs for use by other programs. If you do this, the programs can talk to themselves and can do a certain amount of work autonomously. You don't have to be the guy, basically, it's like, you guys know those old cars where you had to take the crank out, stick it in the engine, and crank the thing up, and then you had to go, right? You can just have a car that just goes when you push a button. You don't have to sit there cranking it, right? That's the idea. That's where we want to go, right? So one of the key design ideas of Unix is universality of interface. All programs in Unix/Linux/Mac, even Windows, are ultimately reading from and writing to a common interface. All programs within a shell are using this common interface. This interface is the standard input streams, the standard I/O streams. STD in, STD out, STD error. The input stream, the output stream, the error stream. These are buffers that your shell maintains while it's running. When you type on your keyboard, your computer is taking key presses and forcing them as characters into standard input. When you guys wrote Java programs, we wrote scanners, right? But at some point, the scanner had to be pointed at something. You had to point it at system.in, right? System.in is what Java calls standard input. Java abstracts that because it needs to work on, it needs to work cross-platform. So one of the things that Java decides based on what operating system it's running on is, where am I getting my standard input from, right? Standard output is the same thing. In Java, system.out.println, system.out. That is again a rebranding of standard output. Does this make sense? So far, so good? Any questions? So, the concept of a pipe, all right, is that we take a stream coming from one program and we redirect it automatically to the stream of another program. So, for example, when grep shows us all of our match results, it is writing those results into standard output. Standard output is what we see, right? Standard input is what we type. Standard output is what we see. When grep outputs into standard output, we can direct that away from us and into another program as input. That's what a pipe is. We are directing output from one program as input to another. Does this make sense? You can do the same thing with variables. You can, we're going to talk about environment variables as well. You can do the same thing with variables, but this is like a little more snappy. It's all in one step. And you can do a bit more with it than just, well, like you can do everything that you do here with variables as well, but this is kind of like, the solution is compact enough that you can express thoughts here that are not quite expressible just using variables. You'll see what I mean. So, when we pipe the output of one command to another, we use the pipe character. This is where it gets that name from. So, let me show you an example. I've got my two data files, data1 and data2.txt. ls is a command which writes into standard output those files. ls pipe to cat. Maybe, yeah. Okay. Xargs, will you fix it now? There you go. Sometimes you need Xargs. So, this standard output was redirected as standard input for cat. Cat receiving file names for standard input does what cat does with files. It shows the contents. Now I needed another little step here, xargs, which basically just kind of takes a standard input and reorganizes it so that it can be read as arguments. It's a step that is often necessary. Like, if you try piping and it's just not working for some reason, throwing xargs in is like worth trying. If that makes sense. But you know, let's see here. Another one that's kind of cat data1.txt. Pipe that to cut line 1. There you go. So, cat is data1.txt, right? Just gives me the content. If I want character 4 from each line, the cut command is for cutting up streams, right? I extract the 4th character from each line of the file, right? You can configure it so that you can cut like between different values, I believe. No? Okay. Well, some of these things that I try, it's going to be like, did that work? No. Okay, we'll move on then. But there are ways of doing it, right? So, other examples. Well, this is kind of the same thing I did. More is another way of displaying things. Sort is a command which takes things and, well, you can imagine, it just sorts them, right? Unique, however, takes something in and only gives you the unique values, right? So let's try that one out. So let's collect up some numbers. Data3.txt. 1, 2, 3, 2, 4. There we go. Save, exit. Cat data3.txt is just all of these numbers, right? If we sort data3, you can see it has lined them all up, sorted them, if you will. If we call unique on data3, it's not so obvious what it's done until we compare the original file and notice that repetitions have been taken out, right? The order has been preserved, but where a file repeats itself, that gets removed. So, if we pipe sort to unique, we get only the unique numbers that are in the file. Does that make sense? Again, the output of one program is being consumed as the input for another program. So, very good. All right. Let's see here. Yes, we did that. Yes, good. Good. Yeah. Okay. Do you guys want to have the break now? Yeah. All good? Yeah.
Yeah.
Everybody's I feel the energy in the room is kind of like everybody needs to go eat something or get coffee or something, so. All right. Let it be declared hereby and forthwith that we shall have a half-hour break at this point in time. I'll even give you the extra minute. Please be here and ready to resume class at 5:30. Thank you very much. Shall we resume? There we go. Shall we resume, everybody? Wonderful. So, before the break we were talking about streams and piping streams from one place to another. Well, it turns out that there are actually quite a few different types of pipes. Nothing can ever be simple, right? So, we're going to go through a few of the basic ones. And we're also going to talk about some places where it is useful to pipe information to, and some places where it is not useful. So, first, discussing the pipe that we have just demonstrated, the most basic pipe. This pipe is used for directing standard output into standard input for some other command, some other program. Commands and programs are the same thing. But only standard output. If you use vertical bar and ampersand together, that allows you to redirect both standard output and standard error. So, do you know what standard error is used for?
If the operation doesn't work.
Yes. So, we didn't really do it in Java, but you know how you can say system.out.println blah 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 hello world. You can also you can also say system.error.println, and you can print stuff to standard error as well as standard output. The purpose of standard error is to contain errors. Anytime a program produces an error of any sort or variety, standard error is where that program is supposed to put it. By default, your command line view is a view both of standard output and of standard error. You get to see both. In some fancy schmancy editors like IntelliJ, things which are written to standard error occur in red text. Things in standard output occur in white text. If it's like, black background. Whatever the default color is. So, In our case, no such luck, but, you know, that's where errors are written to. For example, let's say I wanted to do something silly and wrong. Like, copy a file that doesn't exist. Copy nothing .txt to nothing as well .txt. Right? CP cannot stat nothing.txt. No such file or directory. Okay. If I pipe that, or actually, I kind of need the next one. Okay, this one is for putting a stream into a file.
Putting a what, sorry?
A stream. We'll have a slide on this in just a moment, but it's like useful for this demonstration, so I'm just going to do it. So, if I want to capture the output of CP as a file, that's the guy you use. CP output dot log. There you go. You'll see, first of all, this was not consumed. Right? If I do a working operation, and let me show you the state of the file. CP output, there you go. It contains nothing. Despite the fact that I'm outputting stuff here, nothing was captured. Why? I'm only capturing standard output, not standard error. That's an error message. Right? So, if I instead, if I do a version that would work, so cp data1.txt to temporary.temporary, redirect that to cp.output.log, it'll probably actually still give me nothing. Yeah, but if I put this in verbose mode, let me show you what verbose mode looks like on CP first. Right? So the V flag puts you in verbose mode. Most commands will have a verbose mode. It just means it gives you more information about its operation. In the case of CP, it says, I am copying from data1.txt to temporary.temporary, just as you asked me to. In this case, it looks like a fairly trivial thing because that's just literally what we just told you to do. Thank you very much. But if you're doing something a little bit more complicated, for example, CP in verbose mode, everything, well, let me make a new directory. Make dir temporary, copy all .txt files into temporary. There you go. It shows you every single file that you've moved and where you moved it to when you're using more complicated expressions, which is useful. That's useful, right? So I can capture that output using this guy, right? And you may notice that like these expressions are starting to get a little complicated and have a lot of symbols in them. This is beginning to resemble a regular programming language even, yeah? This may even be resembling quite a compact programming language that can do quite a lot in just a few characters. CP output.log. You'll notice for the exact same operation, this stuff is not consumed, right? Up here it's not consumed. Here, it's not shown because it's being consumed, right? The file stream is being redirected to this file. And if we take a look inside of it, there is the data. That's now saved in the file system, right? So we can take output, we can capture it, and we can save files from it. This is, the most basic version of this is a log file, but there are other things you can do with this as well. Make sense? So far so good? Alright, are there any questions? We haven't had a lot of questions today. Maybe that's been because the lecture's been a little on the boring side, but, you know. Yes?
I actually have a question about like standard input and output.
Sure.
Do different processes like have their own standard input and output, or is there like one global standard in, standard out on the system?
So, the answer to your question is not one nor the other, but somewhere in between. This shell, this command line interaction, has its own standard input-output buffers. This is not the whole system, right? We can have several shells running at once. Each one has their own independent standard input and output. So it's not system-wide, but within this shell, it's effectively, like it's shell-wide,
Okay.
right? But it is not between individual programs. Does that make sense?
So I guess, but would multiple programs then share standard input sometimes, or?
Yes, that's the whole point, right? Multiple programs, like, running at the same time, I guess is the question.
Yeah, because I was just like, what if something tries to push something to a standard input, and then it accidentally goes to the wrong program and something like that is what I was thinking.
So, this is not generally something we have to worry about within the context of a single command line interface. Most of the time, when you're running command line programs, you're not given the prompt to enter a new one until the last one has finished. They're somewhat linear, right? So that neatly avoids the problem that you're describing. This is not always the case, though. Essentially, what you can do, if you have background processes running inside of a shell, that is a thing that is possible. What you essentially do is you disconnect the background process from standard input and output so that those buffers can be used by whatever the active programs are. Does that make sense?
I think so.
Thank you for your questions. Are there any other questions? Yes?
A little bit off topic, but are we going to cover SSH tunnels in this course?
Ooh, I don't think we are. No. I mean, I can show you how to do one quick, but like covered as like in like theory wise, no.
Okay. Yeah.
But yeah, so very briefly on the subject of SSH, y'all know PuTTY?
Yeah.
PuTTY is a Windows client for SSH. SSH is the program that's running behind PuTTY, right? It is possible to just do it using SSH, the command. You say SSH, then your username at the server name, csunix.mohawkcollege.ca in this case. It says that you'll notice this, alright, yes, please, yes, thank you. You may notice your CS Unix splash message, right? You guys have seen this one before. My password, which is 1, 2, 3, 4, 5. Can I enter it? Go. There we go. Yeah, I just logged into CS Unix using SSH. This is just a terminal session being run now on CS Unix. You know, there's my public HTML. There's probably an option you can set for this, but by default, SSH won't show you the pretty colors so you can see what is a folder and what is not. So like, you do lose some functionality when you're SSHing in. There's probably ways to restore it, but you know, I've never really cared enough to bother about it, you know. But yeah, so that's how you create an SSH tunnel. In terms of going into the theory, it's like, maybe ask one of the networking professors, eh?
Yeah.
There's another sister command to that. Exit? There you go. There's a sister command to that called SCP, which allows you to basically duplicate the functionality of FileZilla or WinSCP. Oh, WinSCP. SCP, right? But basically, SSH is secure shell. SCP is secure CP, which is the CP command, which is copy files, right? So I'm not going to go into usage on this, but you know, there's lots and lots of good documentation on the usage of SCP on the internet. I have to look it up every single time I use it. But yeah, that is the command for moving files around across things that you would log into. Make sense? Any other questions? Even off-topic ones? All your Linux questions answered. Yes?
I don't want to go too far down a rabbit hole, but whenever I don't use SCP, I use SFTP, usually transfer files. What's the difference between those two?
Probably not much to speak of. I believe both are using the FTP protocol. They're probably just, you know, different programs that do the same thing. There's probably like some differences, but they both work. So,
Okay.
SCP might be the older one. I'm not sure. But anyway, good. No, I mean, like, I'm only really happy and comfortable if we're off topic during a lecture, so. So this is the little guy that we were just talking about, redirect, right? But notice, this guy is only redirecting standard output. That was the whole point I was trying to make. Is when CP was producing an error, that error was not captured, right? So when you include the ampersand, that redirects both standard input and standard error to the same file. You can, even if you want, direct those separately to separate files, so that errors are logged in an error file and non-errors are logged elsewhere, for example. Or errors are just, you know, not, you know, when you're running a program, occasionally it'll say something like, errors encountered, check the log file, but it won't actually tell you what the errors were sometimes. That's, you know, where you're that's what they're doing. Yes?
Can you get like granular with this? Like, I'm imagining like if I was debugging something and I only want like a certain like set of responses that I wanted to actually care about and ignore like the other maybe warnings or other stuff.
Mm-hmm. Well, the workflow we're kind of describing here, everything gets logged because everything might be useful, and then you use something like grep to grep out things you're interested in.
Okay.
So, yeah. Does that make sense?
Yeah.
Yep. You can also use arrow arrow to append the output file. This is useful. Perhaps I'm about to say too much, but often when I'm, investigating instances of plagiarism in some of the lower semester courses, I'm often using some of the techniques that we're talking about right here, including a program we're going to talk about called diff. Diff finds the differences between files. What I'll often do is I will append diff output to, like a running chain if it's multiple files, capture the diff output, put it all in one big text file, which I call evidence.txt, and then that's what I upload to Mohawk's system to prove the instances of plagiarism. I know nobody except a Linux person will be able to read the log file. That's why I'm involved in the process of actually, prosecuting the person after I've submitted the paperwork as well. But these are techniques that I actually use. So, for example, ls, let's say cat data1.txt, right? I'll just use diff, or, cp data1.txt to data4.txt. I will make a modification, nano data4.txt. I hope you're feeling well, and I hope this isn't plagiarism. Save, exit. Diff data1.txt, data4.txt. It's telling me that this, the file on that side has this extra line, right? If I capture that to a file evidence.txt, if this is getting too real, just let me know, I'll use a different example. Cat evidence.txt, you can see that's my diff output, right? If I want to do a couple more diffs, say I want to diff data 2 and data, where'd it go? There we go. Data 2 and data 4, append it to the same file, there you go. You can see that data 2 and data 4 have nothing in common at all because they're entirely different files. But you'll notice everything was concatenated together into the same file. That is the purpose of the double arrow. It's append mode. Make sense? Question?
What would it do if you only used a single arrow?
It would overwrite. Overwrite. Right? The this bit no longer exists. If I continue to append, right? 1, 2, 3 strikes, you're out at the old ball game. Right? But if you use just a single, just one. Make sense? Question?
What's that 12C14? What is that?
These are lines 1 to 2
Oh, okay.
of, I'm not sure what C means, but
Okay.
that's lines 1 to 4,
Okay.
right? 1 to 2, 1 to 4. It basically just tells you what line number the match or lack of match was.
Okay.
Any other questions? Professor Korkegan tells me he uses a similar method, but because he's not a Linux person, he has to use a Notepad++ plugin. Which I'm sure works very well, but So, sometimes a program can be very yappy and just give you way too much output. In such cases, you can redirect the stream to dev, root dev null. This is the null device. It is the great big black hole that you shoot data into and it never returns. Any streams redirected to the null device file, you just lose. It's like, delete this please. That's your waste paper basket. I can't think of a basic command that gives way too much output off the top of my head. But yeah, anyway. Good. So that is capturing output. We also have the ability to take files and click them into commands as standard input. So, for example, sometimes it's useful to, like, when you're doing like pipe operations that are otherwise, intermediate operations in a pipe operation, sometimes it's useful to like just save a copy to the file system so that you can not have to regenerate it every time, It's like, it's also useful to be able to like pick through it and see what the thing's actually doing for debugging. You can take that and then redirect that as input to a program. So let's say we want, let's see, are you giving me an example that's useful? You are not, okay. MySQL has a command line interface as well you can use, but that's not really a useful example in this context. So, here's one. ls.l, let's leave the star up, there we go. So, all of our files, date modification, all that kind of stuff, right? We can save that to file data.txt, sure, cat file data, you can see, there's our ls output. Now, let's say we wanted to know if anything has, executable permissions for the group. All right. Cut character 4 pipe in, what did I call it? File.data. .txt. That one. Right? So the cut operation, which we've discussed before, cutting out the fourth character of each line, but the lines are being provided by the file rather than having been piped in from somewhere else. Does this make sense? I know this is all kind of like abstract, and it's like, this stuff doesn't really come alive unless you have a specific problem that you're working on, right? It's kind of hard to see what the utility is, So, let me see if I can't motivate this a little bit. So, the ways that this can be used is to build test suites. Now, all of you learned how to do testing using, what was that program you guys used in testing? What was it? Selenium?
Selenium,
Selenium?
something like that.
Yeah. Yeah, you can just do it with a command line terminal as well. When you send a file to standard input, that can be consumed by, for example, a Java program, right? Like all of those Java programs which you wrote where it's like, you know, enter the number of vending machines, 2. Press 2 to press this, to do this operation on the vending machine, 2. Wouldn't it be cool if you could just collect up a bunch of those options in a sequence, send it all into the program at once, have the program execute, and then read the output to see if it's screwed up? Or even better, check the output to see if it's screwed up against the output it's supposed to have. Right? First step, you can write your test cases in a file. Second step, you can pipe that file into your Java program. It will then be consumed by the scanner, right? Consumed by the scanner, taken as input to program. It then produces output. You then have another file, which is what it was supposed to output. You diff those together, see if the Java program did what it was supposed to do. Does that sound useful? That's useful, right? That's automated testing in Bash. No programs, no GUI to learn, no Microsoft specific anything. You can just test a program by giving it input and reading its output and comparing that output to what it's supposed to output directly, right? Put that in a Bash script, put that on your resume and say, hey, I know how to do stuff. And they're like, oh yeah, okay. Looks like you know how to do a couple of things anyway. So, I've already been using this this guy quite a bit, cat. It can be used to concatenate files, not even just using the append, right? Append is useful to know how to do as well, but you can also just concatenate a bunch of files together using cat. But the problem with cat is that when you give it multiple files, it dumps everything into standard output. So, if you capture standard output in a file, voila! You have a thing that merges files together by putting them together end to end. Does that make sense? Ooh, okay. That reminds me of another program that you would find perhaps useful. So, OMG Linux. So, you know how like PDFs are a huge pain in the ass? You know? There's a whole bunch of command line tools to like, you know, slice pages out of them, concatenate PDFs together, you know? PDF Unite. I have a script which generates tests from LaTeX source code, and like it generates the test, and then it's like it looks for a file called attachment.pdf, which is like usually like, you know, like the on the Java test, that all those block diagrams, or the the UML for all the classes they give you as the last page. It's like I just have that as a PDF, and I just use this to staple that to the end of the other PDF, and voila! The only thing that doesn't work is the page number on the last page, but that's okay. I don't care about that so much. But yeah, you can do the same thing with PDFs quite easily. Aha! Diff! Oh, C means change on diff. A is add, C is change, D is delete. So it's telling you what the what was it that was done to the file. That was your question.
Yeah.
Yeah. Yeah, diff. Show me the difference between file 1 and file 2. Very, very useful. You know, occasionally when I get submissions for, you know, Java, for example, and I I run diff on the 2 versions of the files, and the only thing that shows up in the diff output is comments. You know, it's yep. It's output an array of dice, output a collection of dice. It's yeah, okay. You didn't put much effort into that one, but yeah, I've already demonstrated how this one works though. Any questions about diff? Very useful, very, very useful. Yep. 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 Okay. So the reason I'm jumping over all of these is it's here's an example where a line was added. Here's an example where a line was deleted. Here's an example where the lines were changed. So yeah, okay. So if file 1 is ABC and file 2 is ABC123, then A 123. Oh. In the same cases, if we say F1, F2, then this guy was added because he's in the second file. But if we reverse them, F2, F1, this was deleted from the first file, right? Because deletion and addition are inverse operations of each other, right? And changed, A, B, C, D, E, F, G, H, I, J, K, L. If these 2 lines are changed to 1, 2, 3, 4, 5, 6, oh, you get a C. So the question is, in our case, I was adding a line, so why did it say C? Right? It was 1 and data 4.txt. Oh, it does say A. Oh, there you go. There was a C though, wasn't there?
C.
Probably in there somewhere. The C. Well, that does make sense because it would read that as change, right? Yeah, even up here it's reading as added. Yeah, so it worked. It's working as expected. Always good when things work as expected. Okay. Oh boy. You guys ready for sed? All right. I'm really strongly not making the joke I want to make. So, but anybody who's watched The Office knows the joke I want to make. So, sed stands for stream editor. It does a lot of things. This is only scratching the surface on the things that sed can do. But the thing that it gets used most often for is a kind of system-wide find and replace. This little bad boy can be a regular expression. This is substitution text. So you can use regular expressions to search many files, substituting a substitution in them. That's a useful thing to do, right? One thing that I've been doing over the last couple of weeks, I've been teaching the database theory course this semester, and I have to make a test. So what I've been doing is I've been taking the god-awful Canvas quiz, and I've been taking the questions and encoding them in nice, lovely LaTeX because it's what I do, and I hate myself. But I might hate myself, but I hate Canvas quizzes more. So I take them over, I put them in. Lo and behold, the template that I was using to produce these things had an error in it. So every single one of these 50-odd files had the same typo. Now, I either go through 50 files, making that modification, or one call to this, boom, you're done. Now, I must give you a word of caution. This thing is almost too powerful a tool to be used. It will perform exactly what you ask it to do, everywhere you ask it to do it. In one file, okay, sure. All .txt files, I suppose if you want, you can do this to your whole damn operating system if you want to. You'd need sudoing privileges to do this in root sectors, but you can do that. You can do that. Now, this is what I do because it's an easy command to screw up. First, anytime you want to perform a substitution, do it on one file before you do it on all files, please. All right? Number 2, have a Git repo and make a commit before you do this. All right? Because if you do that and you mess things up very badly, it's as easy as git revert, and you get your old files back. All of your said adventures have been erased from history. But it's extremely useful, but it takes caution to use this one. So let's throw caution to the wind. Let me just see here. If one, what am I talking about? It's data one, thank you. So, let's say we want to replace every occurrence of a lowercase 3 with the number, or every occurrence of a lowercase e with the number 3, because we're doing some kind of elite speak substitution. Right? Said. It is important that these quotes, these single quotes, all right? Command line and bash scripting recognizes the same distinction between single and double quotes that PHP does, right? You guys remember how PHP handles single and double quotes? And somebody tell me. Anybody? Anybody at all? You were nodding.
So like, if some variable is written in double quotes, we can get its value, but if it's in a single quotes, it's treated as a normal text.
Yes. So single quotes is like, this is literal string characters. Do not modify, do not play with this past this point, right? Double quotes, you may also perform substitutions into the string. Bash also recognizes that precise distinction between single and double quotes because this is where that came from, right? Bash came before PHP. So, that's why, in the case, like, if it's got single quotes, bloody hell you'll use them, alright? In this case, it might be because the slashes might be misinterpreted as file directory divider character, right? In this case, that's not it, right? Although this looks like a file path, this is not a file path, right? Sed is a kind of a funny program. It is very, very old. There was a time when you didn't have programs like Nano and Vim. You only had this thing. Alright? That's how old this thing is. So, this is a command character. This tells you what sort of operation you're performing. This is like argument 1, argument 2. There's also a spot for another command character at the end. So, they look like they're a file path, but it's not a file path. Okay? So we were replacing every lowercase e with the character 3. In data1.txt. There you go. Hello. This is some data. Ooh.
Except it's first occurrence, right?
Hmm?
First occurrence.
First occurrence, yes. So it's only doing the first occurrence, but you can fix that by using the second option to say G for global.
Got it.
There you go. Now, what it has very safely done is it has dumped this into the standard output stream rather than saved it to the file. Right? So what if you want to live a little dangerously? If you use the I flag, I standing here for insert, no output to standard output. Data1.txt. The modifications are just made to the file. Now, this is not that difficult to reverse, right? I can literally just, run the thing backwards. But you can see how this would become a problem, particularly if you were using regular expressions, right? So, yeah, and the fun thing about that is, this guy here, the last argument where you're specifying the file, that can be a glob pattern. A glob pattern which matches many files, right? For example, here we go. Perhaps // which it means everything in the folder above me. I'm not going to do that. Make sense? So, I've often said like when I'm teaching a coding course, that find and replace is your best friend. It really kind of doesn't matter what editor you're using. If you are a coder, find and replace is your best friend, right? Especially if you know how to do it, like a lot of like routine programming tasks can be accomplished using, you know, using things of that sort, you know? Like, it's like, oh man, I need to insert like one space after every comma in this block of numbers that's supposed to be a two-dimensional matrix. It's like, you could go like space over space over space over 30 gazillion times, or find and replace, comma becomes comma with space, boom! And your work is done. And you can go home and hug your children, pet your cat, have dinner, and go to bed at 3 o'clock in the afternoon.
Is that anecdotal?
Slightly. You'll find that portions of the lectures do become autobiographical at points. Yes, but it is actually true that like if you use your intelligence to minimize the amount of busy work that you do, you have a happier life because you're less stressed out by your deadlines because you can do your work on time, right? Like one of the like very, very excellent reasons to learn CLI and become good at it is that it has like a crazy high skill cap. Like we are literally only talking about the bare bones basics here. You can get really, really good at this stuff with practice, and you can accomplish in a matter of minutes what takes other people like days to weeks of work, like actually, you know, like programming is kind of one of those interesting disciplines where like one good programmer can outwork 10 bad ones, you know, or 10 junior programmers. You don't even have to be bad. Maybe your skills are just underdeveloped because you haven't been in this that long, right? But like literally, like you can become quite amazingly good at this stuff and be able to do amazing things if you learn this stuff. So anyway, question.
An example would be like the plagiarism thing that you said, but takes someone like that knows what plugin to do. We can just do with some scripts and like we're checking the typing switching to.
So I don't do that, but I should. Basically, the problem that you run into there, like, let's say I'm doing a bulk download of one section of Java, 40 students. Let's say let's say 5 Java files for each assignment, right? So I've got to run this diff comparison 5 times on 40 files, right? If I'm comparing every file to every other file, how many comparisons do I have? You have 40 squared, right? So the number of comparisons that you actually have is 1,600 comparisons. In order to usefully use that, you basically have to write a program to tell what meaningful diff output looks like, but that only considers cases like where you've anticipated what useful diff output looks like, right? Like one case is, everything that I get with diff is a comment, which means everything that's not a comment is the same. That is like such a fractional number of the types of plagiarism cases I get. I'd spend way more time writing that program than I would get back from catching the plagiarists, right? So like everything, like one of the problems that you have with this kind of stuff is like it's easy to fall down a rabbit hole with it and spend 4 days writing scripting and bash scripting and stuff that only gets you like a minute or two of advantage every time you go to grade, right? It's like you have to be careful that you're using your time effectively to, you know, to optimize other parts of what you do, right? Like, perhaps not surprisingly, but XKCD did a very good chart about this. Yeah, this is the guy. Is it worth the time? How long can you work on making a routine task more efficient before you're spending more time than you save? Right? So it all depends on how frequently you do the task. And like, when it comes to automating Linux tasks, this is very, very highly applicable, right? Like, anytime you enter a command, you're probably taking a couple of seconds to do it, even if you know the command and you're good at it, right? So if you're entering that command, say 5 times a day, you are justified spending 2 hours writing something so you don't have to enter a command. This can be as easy as like taking 4 commands that you tend to run together and putting them in a bash script. And that, my friends, should only take you 2 minutes, right? And that's where you get your time back, right? You get your time back, you know, you've saved 5 seconds a day, but over 10 years you're up time, assuming that's a task you need to continue doing, right? If it's something that takes you 5 minutes a week, you are justified spending 21 hours removing a 5-minute task that you have to do weekly. Right? So if you can do it in less than 21 hours, that's even better. You still have, okay, though, all right, everybody, listen, this is very important. There are some tasks that you can't do this with, all right? Like brushing your teeth, okay? Brushing your teeth takes the amount of time it has to take, you have to do it every day, and you can't automate it, okay? So just relax on the teeth brushing, it's just one of the things that you have to deal with because you are, in fact, a biological entity. You gotta do that, you know. Don't try to shave down on your toothbrushing time, okay? Your dentist will thank me. But this one's kind of interesting, right? If it takes you 1 day a month to do something, you are justified spending 8 weeks to try to not have to do it. Again, please do not imagine that trips to the dentist qualify in this category. Although, if you can invent a machine that cleans your teeth perfectly for you so that you don't have to visit the dentist anymore, there might be some application for that in wider society. So, although, I don't know, maybe you'll get your kneecaps broken by the dentists, the Teamsters Union or something, but, you know. So, where are we
Have you
here?
seen the movie WALL-E,
Yeah?
where everything's just like robots and everything's done for them? Is that what society will look like one day, do you think?
See, no. I don't think so.
No.
Because, like, that's kind of a philosophical point.
Yeah.
I don't know if I can get into it. Basically, human beings are kind of like, they kind of inherently resist automation, human beings, you know? Like, not only the problem I aforementioned with like the dentists Teamsters Union, like people will protect their economic interests, which often run contrary to increased efficiency, but also, you know, when it enters into a particular sphere, when it like kind of travels too far outside of the kind of Linux command terminal, it starts becoming deeply dehumanizing. Increase, like, the mad rush for increased efficiency. So we kind of have to be inefficient to a certain degree because, like, otherwise we lose our sanity. So preservation of sanity is a higher goal than increased efficiency. I would not go insane trying to make your life more efficient. All right? It's my advice to you.
Yeah, I like that answer.
But, like, honestly, I think people are doing a pretty good job of turning society into the WALL-E society, kind of in a general sense. All we need is the invention of the floaty chairs and we're done, you know? So, this is one example of a way that you can pipe stuff into Stream Editor and work on it, right? Echo, by the way, the purpose of echo, it just takes a string and it bounces it from standard input into standard output. That's all it's really doing. Another useful one is to combine sed with a command which I don't think we're going to cover, at least in the slides. I'll probably show it to you, which is called find. Yeah, this is actually the last slide. Let me show you find. Find is a really useful one. All right. Would you like to see every C source code file in the Linux kernel? Find name in the current folder. This is going to need super user privileges. Glob pattern.c. What? This one goes there. There we go. There you go. Every, or at least those that I have permission to access, there's every C source code file in there. Images.c, gconf. Don't ever cross gconf, by the way. There are some of these files you just if you have, like, there's like some territory in Linux. I'm sure people who are Linux people know what I'm talking about. It's like, man, you are in dark water with no boat, you know, with some of these commands. If you're having to, like, look at drivers, like, it's possible people learn these skills, but, you know, don't try to get your Wi-Fi working on a laptop in Linux like pre-2002. Let's just say. All right. So that is a command that finds every, like, the path to every single C file, right? If you wanted to, you could then pipe those into sed and perform some kind of find and replace over all of those at once, right? But don't. But you could, right? And most importantly, what you've done is you've taken sed and you've targeted it at only those files which you've found using find. Does that make sense? At the moment, though, sed won't do anything because it will just do it over this, which is the standard output. So if I do sed s headers footers, yeah. There you go. You see it just says footers instead of headers, right? Yeah, yeah, yeah. in order to like read those files in, notice I'm not using the I flag. Once again, you have to use xargs. And it's actually dumping the actual source code, and anywhere a header would have occurred, it would have been replaced with footer, right? So does that kind of clarify what the difference between xargs and not using xargs is, right? What xargs is telling the pipe is, take this standard input that you're getting, pop that in as the argument, not like the standard input, right? Sed kind of exposes that pretty well. As arguments, it takes the file names. As input, that's what it's working on, right? By using xargs, we're now taking this thing that we did edit as like, you know, just the text we're editing, we're now considering it an argument, file names, here you go. Make sense? Good, good, good. Any questions? Any unrelated questions? Any philosophical questions? No? They're like, get on with it! Environment variables.
This is not a nature class.
Okay?
I'm just saying this is not a nature class.
It's not a knee-jerk.
A nature class. Nature.
Nature?
Yeah, this is environmental variables.
Oh, no. Yeah, that's a good one. No, yeah, see, this actually presents an interesting philosophical conundrum, which is what is meant by the term environment in this case, right? Because we are not talking about the rocks and the trees and the streams and the fields and the flowers. We are in computer world. In computer world, your environment is the memory space that you inhabit, right? So, another way of saying environment variables is to just say variables. Bash can have variables. In fact, there are quite a few variables that it keeps by default that it uses for various things. For example, user. This is going to seem a little PHP-like. You guys see where PHP gets it now? So, Bash variables are a bit different from PHP variables. PHP variables are only imitating them. The $sign here is memory access operator. When you're assigning to it, you don't need it. I can create a variable. I can say x is equal to 5. Notice I have not used any spaces. Echo x. X is equal to 5. What if I have spaces? Command not found. So, variables in Bash are kind of weird. There's no data type except string, for one. Everything is string data type. These things can be the names of commands and programs. For example, if I say that x is equal to cat, and I say x, oh man, where am I even? I'm in root? Get out of there. If I say, is x still the thing I said? Let's see. Yes, it is. if I say x of data 2.txt, you'll see, uh-oh, did it just do cat? Ooh, right? Your commands themselves, like, how do I explain? The variables can compose the very syntax of the language itself. So if you consider program names to be part of the language itself, which is not really true. I mean, you can do even really crazier stuff like this. C is equal to C. A is equal to A. T is equal to T. C, A, T, data2.txt. Ba-boom! If you want, you can split your command across multiple individual variables. Don't do this. Don't ever do this. This is purely for the purposes of demonstration. So why does this work? Why on earth? Why? Why? It's how it's being parsed. This thing is being taken and it's being pre-processed before it's being executed. One of the ways in which it's pre-processed, all variables are substituted for their values. Right? So, C is being substituted for C, A for A, T for T. C-A-T spells cat. Cat, cats. So, yeah, that's what it does. Have I blown your mind? So what is this stuff actually used for? env gives you all of your environment variables. Now, you can see how a lot of this is like kind of configuration type stuff, right? But reading this, it's like, oh yeah, no, that is actually useful, and hopefully this doesn't look like too awful. Some of this should be intelligible to you. For example, shell bin bash. That is the directory in the operating system where bash, the program, is located. If you're in a shell other than bash, it will say so there. Language, English, Canadian. Not even US, it's Canadian English. Yes?
What is a GNOME desktop session?
This is deprecated.
Yes, but what is it?
So, I have to speak a little bit historically. It's not the GNOME you think it is. Dungeons and Dragons player? Yeah? So, this is Linux Mint. Linux Mint is based on Ubuntu. Ubuntu, in turn, is based on Debian. Debian is the distro for the GNU project. GNU. Let me show you. The GNU operating system and free software movement. This is a very, this is very important historically for Linux. Come on. Don't do this to me now. All right. So, GNU underlies a lot of Linux stuff. The licensing under which a lot of open source software is released is the GNU license. Debian is the GNU Linux variant. Like that's kind of where it's centralized. This is the GNU, as seen in TuxCart. GNOME is the GNU desktop environment. It was originally developed for Debian, but it's kind of like old and nobody likes it anymore, and it's like, for me, it's always been a bit too Mac-ish for my tastes, but like, of all of them, like, a lot of desktop environments you'll find are kind of like, we made Windows XP, you know? Because Windows XP was good. Why don't you like Windows XP? Everybody likes Windows XP, right? Even Windows is doing things that look like Windows XP now. So like tastes in desktop systems change over time. Can I show what GNOME Classic looks like? Just as a, yeah. Here you go. This is what GNOME Classic looks like. Basically up here is like kind of like your start menu, but similar to a Mac. It puts a lot of like the particular menus for the program that you currently have active along the top bar instead of embedded in the window. That's your system tray. This is where your programs are open. You've got multiple desktops. This is kind of what GNOME Classic looks like. God help them when I rewrite the server-side course. The VM that I'm giving them is a Debian VM that has this as the desktop environment. Because if you're gonna Linux. But yeah, so when it says GNOME desktop session ID, this is deprecated. It's probably deprecated because this isn't even running the GNOME desktop. However, they would remove it, but removing something from a configuration file is a recipe for disaster. You don't do that generally, you just give it the nonsense value and leave it in there. That's what you do. So that's what that is about. Thank you for the question. You'll see that desktop session is Cinnamon. Cinnamon version, there you go, right? PWD, you guys remember the PWD command? You remember me saying that was just printing an environment variable? It was just printing an environment variable. A lot of this stuff you don't really have to worry about. There is one though that's useful that you need to know about, and that is path. So, this is a list of directories. So, we've been using commands. And you may think, these magic commands, right? They're just computer magic. I cannot touch them. They are the sacred objects. I must write them down in my notebook and memorize them. They are all the commands, right? You too can write commands. That's right, folks. You too can write programs. And you can even have those programs like operational at the level of all I have to do is type the word and it runs. You too can do this. All right? We can do it right now. Make directory executables. CD executables. There we go. So I'm going to make a file. It's not going to do anything useful. Nano. Say hi. No file extension. This is going to be a bash script. With the shebang. Echo. Hello, world. Now, there we go. It is a bash script, echo hello world. Very good, very good, very good. Let's execute it. To execute it, we must modify its permissions to executable. There we go. It's now green. Say hi. Hello world. Baby's first bash script. Now, what if I wanted that to just be a command? Path is where bash looks for the command bindings. So, if I add this directory to path, say hi is a command. Path defines what the commands are by defining which directories they're located in. Okay? So, we can do this in the following way. Path, reassign, not path, path, thank you. You want the old value of path, so this is kind of like a plus equals operation, right? The separator, oh, that was okay, all right. You want to be careful with accidentally hitting enter during one of these. Path, that does nothing. All right. The separator inside of path is colon, right? If we echo path, you'll see user local sbin colon, user local bin colon. It's the separator between these paths. So, if I say path is equal to path colon home tool time executables you can see that executables is now in there. That slash, I hope, is not going to cause any problems. We'll see. And I can do that from anywhere. I can go in Documents. And there I go. That's what path is for. It's better these days, but historically speaking, and some of the older Linux users out there will have suffered through this. Manual installation on Linux normally used to include adding the directory containing the executable to your path as part of the installation process. And normally they would say something like, well, this is different for pretty much every Linux distro, so you figure it out. So, let me show you your startup script, eh? So, within your home directory, you have all of your regular files. If you look a little bit deeper, you will see a lot of hidden files. Remember, if it's got a dot in front of it, that means that it's a hidden file or folder. Bash history is an interesting one. Look at that. You know that thing that you scroll through? Where do you think it stores that? Right? Oh, part of it anyway. That looks like it's everything up to the last one. Anyway, it's been that's from some time ago. But anyway.
I think it's everything before you open the terminal.
Yeah. At any rate, the bash history is kept. So this actually has important security considerations. Don't ever have anybody enter their password into a command line. Or at least not as a bash command, right? You'll notice that a lot of programs where you enter your password, you do it, you enter the command, then the command prompts you for your password, and then you provide it, right? Otherwise, your password gets stored in bash history, which, trust me, any hacker knows where to find that. But that's not the one I'm interested in right now. The one I'm interested in right now is bash RC. Now there are a couple of scripts that are run when you open up a shell. There's one at the root level, there's bash RC, and there's profile, right? Depending on your particular variation of Linux, these or some other startup script might be the one you want. But if you nano.bash RC, this is your startup script. It sets a bunch of environment variables. These ones are interesting. PS1 is actually where the appearance of your root prompt is set. So if I want to say, you know, me, save, exit. It won't happen here, but if I open up a new tab, so it entered it twice. That's okay. It takes a little bit of, and you can see it's like, I lost the green as well, but yeah. Echo, still a bash prompt. Right? PS1 is just what your prompt looks like, right? Normally it tries to tell you something useful, like what your current working directory is. A useful thing that you can do with it is like if you're in a lot of subfolders, the thing occupies like most of the screen, you can like use that to trim it down even, right? So, there you go. Make sense? Maybe. So one thing that you can do in there, nano.bash RC, basically this file is run every time a new terminal session is opened. So if you want to make permanent modifications to path, this is where you do it. You'll notice here, say hi is a command not found. That's because the modification I made to the environment variable in the other shell only exists in the other shell. If I want that to apply everywhere, I have to run that command, basically, inside the startup script. Does this make sense? So far, so good? Okay. Good. Let's see here. Where's my... Where are the notes? Notes, there we go. Okay, so yes. So export, All right? The behavior of export is difficult to understand unless you understand shells and subshells, right? So in our Linux VM, we are running the desktop environment. We are running the Cinnamon desktop environment. From that, we run subshells, which are our terminal sessions. Terminal sessions can have their own subterminals, right? So when you run a bash script, technically that script is running inside of a subshell. It's an instance of bash being run by bash, right? So what export does is it pops it up to whatever the parent shell is. That still doesn't make it permanent though. In order to make it permanent, you have to write it into a startup script. Does that make sense? Is Linux making sense? Like, everything has its place, and there's a place for everything, right? Nothing is magic. Everything is set somewhere, or done by something, right? This is Linux. We do not encourage the view of the computer as a magic rectangle, right? That does the magic when you enter the right buttons into the, you press the right buttons in the right sequence and suddenly pixels change out their color and that makes you happy, right? That's not what a computer is, right? A computer is a tool. Everything that the Linux command line interface is presenting you is found somewhere. It's not magic, it's programming code. All right? Drivers are magic though. Don't worry about drivers. If you have to worry about drivers, you've already lost. You can also unset or delete environment variables using unset. Once again, this is Linux, so don't unset path, or else you will delete all of your commands. You want to try it? The only reason I do this is because it will be local to this shell. Unset path. There we go. Echo. Whoops. Oh, come on. Oh wait, did I do that right? Cat? Cat? Come on. What's a command? Touch? No. Bash, touch, no such file directory. Yeah, there we go. Touch doesn't exist. Right? That works over here. Touch file. File now exists. Right? So yeah. Echo is like a built-in. It's even sub-programs. But yes,
Off-topic question.
I love off-topic questions.
When you say, so you said just touch and then file, and you didn't give it an extension, so it's not a TXT, it's not a .js. What does the computer perceive it as? Is it just text file?
Character encoded file. Yeah. File extensions are an illusion. They don't really exist. The only purpose of a file extension is to tell programs, is this the type of file I can work with or not? There's nothing inherent about a file that makes the file extension necessary or useful. Files only come in two varieties, character encoded and binary encoded. They're an illusion. Yes?
But how come we always have to change our source code files to .txt when we upload them to Canvas?
Because the program that we're using to check for plagiarism doesn't understand that, and it requires it to be in a .txt with the .txt file extension in order for us to run Turnitin,
Okay.
right? But even that is an illusion. The only reason we require that of you is because the program requires that of us. If the program didn't, we wouldn't have to. But like they're like, oh, we don't want to deal with we're kind of using Turnitin for a thing it's not really meant for by having it checked to like programming code. It probably doesn't want to do that. Otherwise, it would accept, file extensions for programming languages. But it's really not built for what it's being used for, which is why that's necessary. But yeah, .txt files are an illusion. It doesn't make it any less of a file if it doesn't have a file extension. Most of your executable files, right? The say hi file that I made. Normally with a shell script, you'd give it the .sh file extension, right? Say this is a shell script .sh. It's also for documentation, right? But in that case, I wanted to just call it as a command without using .sh, so I just left it off. It's up to you. You get to name what the files. You get to name the files. The file name is entirely in your control. But again, the file name is entirely in your control. This is Linux. You can do whatever you want. If you can dream it, you can make it reality. Question?
Question.
Yes.
Path. So it's using different. It's just not using like a text file. Like what exactly? I'm still a bit confused about what path actually is doing.
Sure.
Can
So.
you read out of it? If you ask Linux to read path, you can.
Yes. Yes, the answers are there too. Yeah, so these are just all of the locations on the computer where executable files happen to be stored. It's pre-configured and it's dependent on your Linux variant. But if I navigate to, for example, user/local/bin. What do you mean? There's no such file or directory. Did I misspell it? Can I go to root, please? I'm in root. cd. Oh! Again, it does exactly what you ask it to. User. Right? My session has been usurped. USR, thank you, local/bin. So, you remember apt?
Yep.
That's where apt is stored.
Okay. So now, this is like more in depth, and I don't know if there's an answer to this question. So like you can like just say I have no idea. You said that the end of a file that is just organized, like it's showing the system how it's supposed to be read for other files, right?
For other programs, yeah.
Yeah. So .exe and .txt don't really have an effect of the contents of the folder besides how it's read.
Yes, they don't have, the file extension does not affect the contents of the file. The contents of the file are separate.
Okay.
Yes, there's no interdependency.
I know this would make it, so changing that, out of curiosity, would you be able to change the names of the ending of a file, like .txt or something else?
Sure. Easily.
But it would be unreadable to anything, like, because it's looking for TXT, but you'd be able to do that and have it function similarly, right?
Yes. You could even change it back and then it would work again. The one thing that you can't do usefully is go from binary files to character encoded files. And like you can't cross that boundary. Let me show you why. If we go to copy image, no, I want to save it. Firefox. Google, that's it. Cute. You're cute kittens. There we go. That's good. That's an image if I've ever seen one. Save image. There we go. Save it to, oh, it's a .webp. Fine. Fine. Save it to downloads. That's too small for a kitten. I'm sorry. That's too small for a kitten. You crossed the line. Get out of here, Update Manager. So,
Oh, yeah.
if I go to downloads, am I even? No, I'm in root. Downloads. There we go. You'll see my file, right? MV is move, that's rename. So if I rename it to, rename webp to 1440.txt, for example, it works. I wonder if I have get it here. Do I have get it here? I do. No, I don't. I will soon. There we go. Boom. Get it. What was the name? There we go. Get it is basically like a notepad equivalent kind of thing.
Okay.
It just has a scroll bar, right? Edit anyway. So I can do this. I can scroll through it and show you the nonsense.
Yeah. Okay. This
Right.
is cool.
So if you take an image file and you interpret it as characters, you get nonsense, right? If you take a text file and interpret it as binary information, you get nonsense. But text files generally are made to be interchangeable with each other. Like interchangeable with each other is the wrong way to say it. Everything is encoded in the same format at the end of the day, right? Now, if a file isn't expecting something to parse as JSON, for example, you better be sure that it parses as JSON. If you take a file that's not JSON and you call it JSON, that doesn't magically make it JSON encoded, and it will fail if you try to parse it, right? So that kind of stuff. But if it's just plain text, there's no reason. Like, the file extension is meaningless, right? Some programs will just open anything you ask them to. Notepad in Windows is like that. It'll
Just open anything?
It'll open anything, yeah.
So you can just, even ones if it doesn't exist, like if you, for example, 1440
With no file extension?
ABC, like it's just a random one that doesn't exist.
Absolutely. Move that thing to 144 dot. Professor Moore is awesome, and I love his class. All right. I mean, it's still the same file, but you know. Yeah. The Professor Moore is awesome and I love his class file extension.
Interesting. That's
Usable only by programs I write.
yeah.
Yeah. But like, one place that you see this is like with video games. You'll find that like a lot of the time a video game, like the save file format for the video game is like, you know, if you're playing Civilization 4, it's like .civ4,
Oh.
right? Stuff like that. Like, they didn't have to go talk to an old man in a very long white beard who has a large book containing every file extension and say, I have brought you my empty snail shell and 50-cent piece from the year 1823, the appropriate sacrifice to be rendered into the book of names. Your sacrifice is accepted and appropriate, here is your card. That's not how it works. You just get to make it up. Right? You just get to make it up. As long as you yourself use it consistently, it works. File extensions don't exist. I mean, they do, but they don't, right? They do, but they don't. It's complicated. Your relationship status with file extensions is it's complicated. All right? Make sense?
Yes.
Any other questions? Do I want to say anything else controversial about file extensions before we? Oh man. Let me just see how far we need to get through to get. Let me just see if we did actually cover all of this and maybe hit a couple of points, then we can get out of here. Okay? I'd like to say we finished this one. So yes. So the slides recommend modifying .profile. .-rc also works. Depending on what your Linux variant is, one or both of them will be called at different times, right? Permanently for all users is in etc/profile, so that's system-wide profile. Most of you will not be using Linux distributions with multiple users, but something like CS Unix is, right? When you're talking about web servers, Linux web servers will have, like especially Apache servers, like a buttload of different users. So you actually do have to worry about like users and groups and stuff. Good. We can access environment. Yes. Yes. Yup. Yup. One note about environment variables. Programs will want environment variables set up sometimes to control like what the directory is for what their project directory or stuff like that. You may have to set up miscellaneous environment variables every once in a while, like programs use them. Sometimes it's only one program that wants a particular environment variable and you're like, well, that's a little, you know, you think you're all that, do you? But yeah, it does, and you have to do it. Yep. So you can take environment variable definitions, put them in a file with the fictional file extension .env. .env files consist of key-value pairs on each line, like so, just a bunch of variable initializations. The comment character you will find here and elsewhere in this course is octothorpe. So we're back in Python land. Yeah, that's it. All right. And I'm still recording. Any questions? Yes?
Just a quick one, like not really related to this, but like is there like a way to find, like you know how we did like we take data1.txt and stuff? Is there like a way to find like all the ones we created? Because sometimes we may like forget like a file name or something like that.
Forgetting file names is like, okay.
Let me say we have more.
Okay.
Example, I just forgot something.
To answer your question seriously, in order to find a file, you must remember something about it. Which is, you know, you must know something about the file name. If you can encode that as a glob pattern, then you can search. Or you must remember something about the contents of the file. You must remember some string that's in the file. Like, for example, if it's a PHP script, you know, you can look for something like a PHP opening tag, although that'll only probably give you PHP scripts, right? You have to use some knowledge about the contents of the file, then you can grep for that knowledge, find the files that knowledge is contained in, and one of those files is probably the file you're looking
So
for.
like, can we like find it like if it was like not if it had like .txt or if it had like .something, like can we find it like that?
Oh yeah, I mean you would globally find over like your whole home directory, and then you would search everything and you find it eventually. Yeah.
You can't search for a file based on the date it was created or time,
Ooh.
and kind of like reverse, see like what the most recent file that was created. Is there a way to do that, you think?
LS will have an option for that.
Oh, okay.
Yeah. LS order by date. Well, with the autocomplete.
Okay.
T.
Oh,
T for time.
Yeah.
Yeah.
Or R for reverse. So CD file, CD documents, ls-t. There you go. In order of time last modified, LSLT, and that it's even more useful. If you pipe that to cut by line 1, or whatever man, cut. This is too late in the class to be pulling up the man page for cut. Dang it. Alright, I can't. I have to stop. But yes. Like if you wanted like the 5, actually it would make like a pretty reasonable assignment exercise. Write me a Linux command which gives me the extended list ls output for the last 5 files that were modified. Something like that. You can do that easily. You can do that. You can just do it.
Yeah.
Alright? Everybody feeling like everybody's okay, let's go. Go. I'll stop talking. You can go.